Moving into the last section here, we have Unix. And the penguin here is a good representation for our Linux. That's just the mascot of Linux is the penguin. So why is it called, asterisk Nix? And it's pretty much to include Unix, Linux, any kind of operating system that's in similar design to the original Unix operating system. And it's going to represent all of our different variations of Unix that we have. So here we have Ubuntu. This one is free BSD. Over here, you've probably seen this one if you've spent any time on YouTube for learning how to hack. That is your Kali OS. And also, we're going to include Mac OS. These are all descendants that have similarities to Unix. So Unix, Linux, any descendant of Nix will get the asterisk. So you'll hear people refer to it as, Nix or just Linux in general. Just wanted to be aware of the, asterisk nomenclature, as that's definitely going to show up in your readings. So what kind of operating systems, if you've never heard of, the Nix family and you've only lived in Windows your entire life, that's fine. But there are a lot of things out there that run on Linux. Servers, routers, firewalls, you name it. Any kind of big server that's running in your infrastructure, it's probably going to be Linux-based because they're more lightweight and they're an operating system that's can run on a variety of hardware. So it's just easier and more compatible instead of the clunky, gunky Windows operating system that takes up a really complex file structure and has a lot of extra stuff packed into the operating system, that it's heavier than the lightweight Linux opposing operating system. And these can be very high performing computers. Just because they're Linux doesn't mean that they're not as performing or as good as Windows. They're just two different operating systems. You can have routers. So many enterprise grade routers and switches are going to have a version of Unix, such as Cisco IOS, Juniper, BIOS, you name it. Firewalls. So firewalls are very popular to run on Linux operating systems. Also, your NAS devices, your network attached storage. Those are going to be running maybe like FreeNAS, which is Unix based, and basically don't count out Linux. Linux is also open source. So what does that mean? Well, it's free. Open source meaning it's open to the public to make changes, configurations, modify it how you see fit, learn it, download it for free. You don't have to pay anything. Get started today running the operating systems as you want. You can also download Ubuntu and Kali, any kind of Linux VM that you'd like, to your Windows host to get familiar with the operating system. I would definitely recommend doing that. But open source is definitely a term you're going to hear, basically saying it's open to the public to use as a resource for free. Now in Windows, we talked about the command prompt. And now when we go to Linux, we're going to refer to the terminal prompt as a shell. So console, terminal, shell, command prompt. If you say that, we know what you're talking about. You don't have to be really meticulous and always say shell when you're talking to Linux. If you say open a command prompt and you're on Ubuntu, I'm going to know what you're talking about. But really, shell is more geared towards Linux, and then command prompt is geared towards Windows. And something significant when you're in the shell for a Linux device is the pound symbol or the octothorpe versus the $ symbol. This is going to mean you are the root user. So it might look like root at the operating system that you're on. This is an Ubuntu shell, and this is the root user. You're going to have a $ in front of your command prompt here. You're not going to have your username that you're logged in on for the system and a $, which just says you're a regular user account. This is going to be higher privileged. You're the root user. You're the highest level account that can, well, not the highest level, but a high level account that can exist on the Linux operating system shell. And when you're working on the back end within the shell, It's just an easy way for you to tell that you're operating as a privileged user. So you're going to be able to take more commands, potentially do something detrimental to the machine because you have those added permissions, and it's easy to spot and make you aware that you're making changes to the operating system as a root user. Whereas if you have the $, like Mark does here, this is operating as a regular user. So Mark is not operating as the root user, he's operating as Mark, a regular user. And in Windows, we called this the administrator or the admin account. So in Linux, we're going to refer this as the root account. So on Linux, the administrator account is now called the root user. And for Windows, you can have admin, we can also have domain admin, and we can have system admin. System admin is the absolute highest account you can have on a Windows device, but for now, we're going to just stick with root for Linux and admin for Windows. There are also different shells based on different preferences or your default operating system settings. So for all you Mac operating system people out there, you're going to have a Z shell. I believe that's the default shell now for Macs. And it's going to build off of the Born Again shell, which is the SH, the OG, so the legacy original Unix shell, Born shell. After Born shell, they came out with the Born Again shell. So bash, you're going to hear this a lot. I would definitely be familiar with the term bash and the Born shell. And again, it's a new default standard based on the operating system that you're using. And it also has backwards compatibility with the Born shell. And then I just wanted to include one example here for the macOS command line users. Opening up a shell, you're going to be launched into a Z shell. Probably just get familiar, with the idea that there are different shells out there, different versions of the Linux shell that are going to be based on the current operating system or default system settings you've set on your computer for what shell you're operating in. The Unix command line. So in Windows, we have the /, and in Linux, we had the /. This is how I remember this, and I would remember it if I were you, because it will be very embarrassing if you write C, Windows, users, Haley, and you just keep going with /, and really that's for Linux. Let's try and do our best here for the correct slashes for the directory structures of our operating systems. So the way to remember this is Linux leans. So Linux is going to lean forward, and Windows, if you're going to write a W, starts with a /. That's how I remember it. And maybe we should have made that one a different color, but Linux leans, so going to lean forward, and if I were to make a W, it's a /. Now that you know that, you'll probably never forget it, and you'll never have that embarrassing moment where you're trying to write out a path or transfer something over and not know which way something leans. Maybe you guys have never noticed that the hash, the slashes go one way or another, but it's a default standard for the operating system. Another thing about Unix is that it's case sensitive for all your command lines and files that you're going to search, whereas Windows is not case sensitive. So any command that you're plugging into the shell to try and execute, or any file that you're trying to move, copy, reference at all, it's going to be case sensitive. So if you have file.exe and you try to call this in Windows and you say move lowercase f file.exe wherever, that will execute in Windows. But if you do this in Linux, that is not going to execute. You will have to match it directly for case sensitivity, how the file is being referred to with the capital F. So just remember that. Unix, the one downfall, while most commands are easier to learn in Linux than they are in Windows, is that it is case sensitive and it can be very annoying. With that being said, learning the Linux command line, Unix command line is definitely a lot easier than Windows because it's more intuitive for the commands. Example, in Windows, to clear the command prompt, to clear the screen, it was CLS. In Linux, it's just more intuitive to remember to type clear to clear your screen. PWD is print your working directory. LS, I like to remember this as list the stuff. This is going to list all the contents within that folder or path that you're at. PWD, print your working directory. PS, that's going to output all of your processes that are currently running. Cat, that's going to start typing out the contents of that file. CD is the same as it was in Windows with change directory, same with mkdir, same with CP. So definitely should reference some documentation to getting a basic understanding again of like 25 commands or so to get you started in a shell and see what commands are the same in Linux as they are for Windows, as some of them will overlap, and what the difference is for the commands that do the same thing. So for example, if I wanted to list out all of the processes, that would be PS, but in Windows, that was tasks list. So a couple of differences, and it would just help you learn the commands a bit faster. And again, we're dedicating entire modules down the road to Windows and Linux operating systems. So this is just covering them at a high level for now. Moving into the Unix file and directory structure, again, this is another representation of what a hierarchical structure looks like, starting at the top of the tree at root, which is our leaning slash, our forward slash for Linux. And we have all of these subdirectories beneath root. We have our bin directory, that's short for binaries. So all of your essential commands and binaries, some of the commands that we have discussed in this mod, like making a directory, moving, listing your processes, printing your working directory, etc. We're going to cover a couple more commands, but those will all be pulling from binaries within root and then the bin folder, so /bin. Etc, this is going to store your configuration files for the system. Configuration files mostly end in .conf, short for configuration. Sbin, instead of just binaries like bin, the S is for essential and system binaries. User, that's all of our user information. Read-only user applications and support data and binaries. User bin, user include, user lib, local, user share. These can go pretty in depth. Var is your variable data, and dev, device files, your home path. I would probably remember home. That's pretty much the same as C. Users in Windows. Optional software in your applications. Proc, process and kernel information. We talked about the kernel. And root is your home directory for the root user, not for the regular user of yourself, but for the root administrator account for Linux systems. So what would I take away from this chart? Probably nothing, just an understanding of what we discussed at a high level so that it's not the first time you're hearing about it when you go on to take your A+ or your Net+ or Sec+ security or your Linux+ certifications. Just general exposure to the Unix file and directory structure at a high level. Now, this slide you're definitely going to hate me for, but it's always fun to cover the Linux user authentication and authorization files. So starting with etc passwd, this is going to be used for both authentication and authorization. You'll notice that etc shadow is going to only be for authentication and etc group is only for authorization. So authentication is here, authorization is here and here. etc passwd is the only one that will do both functions. And this is an example of what the contents within the etc passwd folder would look like. And etc passwd is basically a file that contains lines for each user and system account. And each of the contents here is separated by a colon. So JDoe, that's going to be your name. The X is going to be your password. The next set of colons, this 1000, is going to be your user ID field. The next set of colons for 1000 again was going to be the user's group ID, the group that they're associated to. John Doe, that's going to be any comments entered by the person who created the user, the name, J Doe. And then the next set of colons is going to be your home directory. And the last set of colons is going to be your default shell that you launch into. So we discussed a couple different types of shells a few slides back, and this one is set to have this user JDoe, if they open up the shell, launch into the born again shell. Now, how the heck are you ever going to remember this? Well, of course, we're going to make it Sailor proof again. And we're going to make a good acronym for the letters that we have, and it's going to be never for the name, pass for the password, up for the user ID, good for the group ID, cake for the comments put in, have for the home directory that's set, some for shell. So if you can remember, never pass up, good cake, have some, then you will remember all of the colons and what they mean in the Etsy PassWD folder. I guarantee that you are going to learn the Linux system and come across Etsy PassWD and get an output like this. And if you don't know what these are represented in between each colon, it's going to be a really hard time. So just remember, never pass up, good cake, have some, and then hopefully by looking at the values contained within the output of the file, you can kind of remember like comments. This is obviously shell, home directory. So hopefully that one is helpful to you. Moving into the Etsy shadow file, this is actually the one that contains your passwords. So something significant to note, this one has your passwords. The Etsy PassWD does not actually have your passwords. That would be a very common exam question that you would get for which folder, which file within the Linux operating system contains users' passwords. It's Etsy Shadow. It's not Etsy PassWD. And we're going to learn that here. So just keep that in mind as you're going through. But basically, it's going to be the file that contains all your passwords and account expiration information for all users and accounts. There's going to be multiple lines just like this within the Etsy Shadow file for each user. This is just one entry for JDoe, John Doe. And if we break out the groups, we're going to have the username. After the username, hashed password. Now remember, each field is broken out by where the colon starts. So this is actually a condensed version to have it fit kind of in the line of the screen here. This colon goes all the way to the next colon value right here. So this entire string is the user's hashed password. The next set of colons will be the last time the password was changed. And it's actually the number of days between now and, this is an important date in Linux, January 1st, 1970. This is called Linux epoch time. So Linux, for whatever reason, decided to have a value for time represented in everything referenced to, well, how long has it been since January 1st, 1970? I don't know why that is or why it was invented, but I would definitely remember Jan 1, 1970 for most Linux time values. And this is the amount of time in the value of days since January 1st, 1970 for the last password modification, when the last password had been changed. This next set of brackets here for the 0 is actually going to be the minimum number of days between the password changes. So this one is 0. Days since password change. After the minimum number of days between your password change, the next one is going to be the max number of days since the password has been changed. The next set of colons here, so the 7, is the number of warning days before the user is required to change their password. So we'll just put warning. So that's their window. Once they receive notification that they need to change their password, they have 7 days to do so. And these last two values here are actually blank. So this one that's blank is going to represent the number of days after the password change expires and it becomes inactive. And this one is going to represent the number of days, again, from January 1st, 1970 until the account expires. So that's the expiration date. So again, Etsy Shadow is going to cover everything related to passwords and account expiration information for all of your users. And yes, of course, we have a fun mnemonic for this. You have lost many matches. Winning is everything. Ha! So, let's just go with you have lost many matches. U for the user, H for the hashed password, lost the last time since the password was changed since 1970, the M for the minimum number of days since the password was changed or needs to be changed, the maximum number of days a password is valid before the user is required to set a new password, the W for the warning message, that the number of warning days that shows up before the user is required to change their password, the I for the number of days before the account becomes inactive, and the E for expiration. So the number of days since January 1st, 1970 until the account expires. So definitely pretty complex here. I would definitely recommend watching another video resource that probably could explain this a lot cleaner than I just did. But Etsy group, again, just group information for authorization, and we don't need to go through all the entries for that. Mostly just want to focus on Etsy Shadow and Etsy PassWD. Get a familiarity. You don't need to memorize any of these for what they mean, but if you remember some of the acronyms for them, at least the next time you see this, you won't be like, wow, what the heck is this? And well, you'll know what a hash password kind of look like, and you'll know what the name looks like, and you'll definitely know that Etsy Shadow is the one that contains all of your passwords, not Etsy PassWD. Another important topic here that we need to discuss with Linux is UGO. So I always think of this like, was this a TV show or maybe it was a card game? Oh yeah, trading card game. Sorry, I was a Pokemon kid when I was growing up, but I always think of UGO. So that's how I remember UGO. And it stands for user, group, and the owner. And these are going to be related to files for what they can do and the permissions associated with your file. So read, write, and execute is R, W, and X. And if we have a sample file here for a file called myscript.sh, we have a syntax at the beginning. You can do this with the command ls tech l or lh. You can do either one, and it will output the information about these files. And they're going to be broken up into 3 sections. Each of them are going to have their own set of values for read, write, execute, read, write, execute, read, write, execute, and they are going to match up to user, group, and owner. So if we take this same syntax and kind of just blow it up over here, these are the permissions that you can have for the user of the file, for the person using that file, this script here. Group, if you're a member of a group that has permissions to access this script, these are the actions you can take on it. And if you are the owner, the person who created this script, these are the actions you can take on it. There are numeric values assigned to read, write, and execute. They are always going to be 4, 2, and 1. 4 is always going to be allocated to read, 2 is always going to be allocated to write, and 1 is always going to be allocated to execute. So what this file comes out to is if we had the value of 2, the 4, the value of 2, and the value of 1, this gives us 7. On the group section, we have a value of 4, we don't have the value of 2, and we do have the value of 1, so this gives us the value of 5, and we don't have any values set for read, write, and execute permissions for the owner, so that is a goose egg. So this is actually the equivalent of a file with the permissions of 750. We set permissions with the chmod command in Linux for change modifications to a folder. And we change the modification based on numeric values for what we want to assign based on what the user can do, what a group member can do, and what an owner can do. So for example, this is pretty common. If people can't figure out why something's not working in Linux or why a script isn't running, they blame it on permissions issue, and sure, that probably is most of the problem most of the time, and they will default it to say 777 across the board so that each user has read, write, and execute, group has read, write, and execute, and the owner has read, write, and execute. So they have full permissions. This is the highest, most privileged setting you can take on any file within Linux is just chmod it 777 and then the file name to ensure that the users, groups, and owners have maximum ability to conduct read, write, or execute on the file. And you can have different modifications of different values of numbers based on the permissions set here. So if you wanted to have this file only be read by everyone, there's always a beginning dash, and then we want read only for everybody. So we'd break up our 3 sections, and the value would always be 4, and we have 0, 4, 4. So if we only wanted people to be able to read it for whatever reason, that's not very practical, but it's just an example, we would chmod 444 the file, and everyone would just be able to read it. So if you're ever on the Linux command line and you do ls tech ll or lh, you can see the different attributes associated to the file and get a better understanding of who can take what action on that file based off of breaking up your groupings into UGO. Moving into text editors, you want to be aware of how to edit your text files within Linux. 2 most common ones are VI and Nano, and Vim is a VI improved. We'll just say sure for how that stands for VI improved. But anyways, these are your 2 main text editors that you can have. They're used to create and modify your files with the VI command. That's going to come pre-installed with the Linux operating system that you're using. And the Nano may or may not be there, but you can always download and install it if you want to use that as your preferred text editor. You would simply do VI and then your file that you want to edit, and it's going to open up different levels of input that you can take to it. You can write to it, you can literally type out what you want the file to contain, And there are two different modes to be aware of: command mode and insert mode. When you're in insert mode, this is where you can write your essay and all your words that you want to be contained within that file and pretty much insert text into the file. To get into insert mode, you would use the lowercase I, and you can do pretty much just type away for what you want. And if you're actually trying to save the file off or copy any lines, delete any lines, or escape, then you're going to need to be in, or sorry, not escape, quit, write the file, or save it, you're going to need to be in command mode. So in order to get into command mode, if you're in insert mode, it's the escape button on your keyboard, and then you will be sent to command mode. If you want to go back into insert mode, you press the lowercase I. Back to command mode would be escape. When you're done with the file, put everything into it that you wanted to, you're ready to leave it, you would press escape to go back into command mode, and then execute, write, quit, and save. There's different combinations. You can just do write, quit. You can do quit without saving. You can do WQ bang is probably the default if you want to write your changes to the file, quit it, and save it. But a high-level overview of text editors that you can come across in the Linux environment. Learning VI is one of the most painful things you can do. If Nano is available, go ahead and use it, but I've been using VI for so long, or Vim, that I just know all the commands now, and definitely a quick video resource of how to use VI, or maybe a module to get familiar with it yourself would definitely help you out. Another thing we should discuss is file compression and archiving. Two main topics we want to kind of cover here is obviously compression and archiving, and the gzip command will compress the file, and it's going to append the file with a .gz file extension. If you want to decompress that compressed file, it's going to be gunzip for unzip. So G and then unzip. Gzip will compress the file, make it smaller, compress all those bytes together, make it an overall smaller file. And then to unzip it, gunzip, it will extract everything and decompress that file that was previously compressed with gzip. If you ever right-clicked on a file in Windows and pressed extract here because it was a .zip file, very similar concept. It's the same exact thing, just Windows versus Linux. We're not dealing with 7-zip here. We're dealing with gzip and gunzip. tar is a term you should be familiar with for tape archive, and it was designed to archive data to a tape drive. It takes multiple files and directories and creates one single archive file that can be transferred. It's also compressed with the TAC-Z option, so you can have the tar command with a bunch of different switch options to take different actions on the file and compress it that way. Tarball is definitely a term that you should be familiar with, and that is basically the compressed archive file that's stored in its compressed form. All right, moving into operating system processes and ring levels. There's a lot of information on the screen, but we are going to keep it very simple. If we are a user, we're going to live all day in ring 3. It has the least amount of privilege and least amount of access to system resources. Remember we said in the beginning, the kernel is going to be the heart of the operating system. It's also going to be your policeman of the operating system, saying what you can do or not do when interacting with the operating system as a user, or in the command line, or running an application, whatever you're doing. The kernel is the heart of the OS, and it will approve or deny based on something called a system call. So if we're a user and we're hanging out in a least privileged ring here in ring 3, and we want to make a request to the operating system, it's made by obviously a program or a process running in user mode where we are to basically say, hey, I need to do something that's in a more privileged operation than what I currently have at my ring level. Can you approve this for me and run it for me at a higher, more privileged operation? And it will either say yes or no, and it will handle this in the form of a system call. So the system call is the request to the operating system made by the programmer process running in user mode, which is pretty much in ring 3, and asks to perform a privileged operation. This can include reading or writing to a file, creating new processes, allocating memory, read, write, opening stuff, or exiting. So basically, at a high level, you should know that there is ring 0, which is at the kernel level, the most privileged, most protected, and the highest level of privilege associated with the operating system, as it has the most access to system resources, and it has anything that you can contain or think of, device drivers or other low-level system components running in ring 0. And as we move out the ring, the level of privilege will decrease and get less and less privilege to do less and less functionality with the operating system. If there are rings you should be memorizing, that would be the ring 0 where the kernel resides, and maybe ring 3 where the average user resides. And examples of drivers can be within ring 1 or 2, users and applications going to hang out at 3, and the kernel is going to be at the heart of the OS in the most privileged ring at ring 0. Very quick run through of operating system processes and ring levels, but again, this is geared to be a lecture designed to have you learn about these terms so that they're not the first time you're hearing about it when you go prep for your certifications. Talking about an API, this stands for Application Programming Interface, and I don't want you to confuse an API with a system call. So they are both mechanisms for interacting with software, but they have different levels of extraction. So think of an API, it's basically pulling information and interacting with software, such as library, frameworks, or services at a higher level interface application layer than a system call, which is going to be a very low level interface, kind of directly asking information for the ring 0 privileged operating system actions, and it's going to be asking for things like system resources, managing processes, or interacting with hardware devices, whereas an API can really just be something that's requesting information. It can be pulling it off of a website. It can be interacting as something like your Google Maps and overlaying information. Your weather app on your phone can act as an API to pull in information about weather to that application. There is going to be a link in the description to have someone teach you APIs a lot better than I can, but I just put this slide in because we're going to come back to APIs at a later time, but I don't want you to hear the term API thrown out there and confuse it with what we just learned, which is a system call, but they are kind of in par with each other, but they are separate things, so we want to keep those straight. So basically, think of an API. It's just a way to interact with an application or software and pull back levels of information and gain information about whatever it's requesting to pull from that application.